So the first thing that we need to take a look at today is this idea of arc lengths and finding the measurement of an arc length. Now, a couple of things I want you to keep in mind. Remember that when we talk about an arc, we are talking about part of the circle that's here on the outside, right? A portion of that circumference. Okay, so we know that the measure of the arc, this n value that you see here, has to be the same degrees as our central angle. So if this inside angle here was 85 degrees and it's going through the center, then our arc measurement, this would also be equal to 85 degrees. However, for this video, we also need to talk about the arc length. 85 degrees is the measurement, but it's not the length. Our length is really looking at what piece of that circumference are we dealing with. And so just like we know that the entire circle is 360 degrees, we also can find out what the length of our circumference is. And this is one of those formulas that we reviewed as we started class today, right? And we're going to use that to find our arc length. So I want you to here keep in mind that we know that our circumference, right, our circumference is always equal to diameter times pi, or 2r pi, right? And so now if we're looking at arc length, we're going to find a piece of that. So just like we are finding the arc measure is a part of 360, that entire circle around, the length of our arc is also going to be a piece of our circumference. A lot of times you'll see that arc length is also written as S. And so for this video, for your notes, you're going to want to write it as S, at least be familiar with that's what the S stands for. So if we are finding just that S by itself, we can kind of rearrange this proportion a little bit and know that we're going to multiply the arc measure times the circumference and divide that all by 360. You'll notice that these two are related to each other. We've just kind of rearranged it a little bit, but they are the same. These are both equations that we might use to find the arc length. Will you right now in the chat send me a message that just says, I've got the equation for arc length written in my notes? You don't need to send it to me. Just tell me that you have this written in your notes, and make sure that it is in your notes. This is going to be a formative check here shortly. So then let's look at some problems with this idea in mind, looking at the measure of an arc and also finding the arc length. So here's a few problems. We need to determine what those arc lengths or the arc angles are here. You'll notice that we're told that it has a center at point C. This is really important because in order to use those properties that we know about the measure of an arc, we have to have the angle of that inside degree, that degree that goes from a side of the circle to the center point out to the other side. Okay, it also tells you maybe some other information. So in this first problem here, we know that AB is the diameter. That's important because we know it goes straight through. It also tells us that if it's a straight line, this must be 180 degrees. Okay, so a few important things there that we're told. Now, the first question here says, find the measure of angle DCB. So we're looking for this angle right here. Now remember what I said earlier, this measure of our outside arc also has to be the same as that inside angle. So DCB must have a measurement of 45 degrees. Then we want a measure of AD. This actually should be, it didn't convert correctly, should be arc AD. We'll write that little arc symbol over the top, right? We're not finding the line AD, but we're finding the arc AD. So in order to find this arc on the outside, it's helpful if we know that angle on the inside. Now, we know enough pieces to be able to find this, right? We know that this entire side must be 180. And if this part here is 45, then in order to find that angle of this angle here, it's going to be 180 minus 45, or 135. If that inside angle is 135, then my outside arc also has to be 135. Okay, let's look over at this next one. Now again, we know that C is in the center. We are told some other pieces of information. We know that we have an 80 degrees, a 100 degrees. We know this arc here on the outside, which means that this angle must also be 110. Now this question here is asking us to find the measure of arc RS. So if we can find what this angle is on the inside, it will match what the measure of that arc is. Okay, so if we add up all those parts that we know, they're going to add up to 290. And I know that the entire circle must be 360. So it means that I must have 70 degrees left. If that inside angle is 70 degrees, this outside arc also has to be 70 degrees. Okay, so a couple of really important properties here. Make sure that you get these kind of ideas in your notes. The first one is that the measure of the inside angle is equal to the measure of its arc. We also just looked at the fact that all the degrees in inside angles or in those arcs must add up to 360. We know a circle all the way around is 360. Okay, so those are two important key things to keep in mind. Let's take a look at another one. Now here's another sort of problem here. Let's look at these examples together. The measure of AC, here's our AC, must be those two pieces put together. So AC is going to be 80 degrees. The measure of AEC, now remember, if it gives us three letters, we're doing the major arc, which will go the long way around this circle. Right, so AEC must be the measure of these added together, which means AEC is going to be 290. finally, let's look at one last one. The measure of arc BD. It's going to be those added together. So we'll have 20 and 75, which means the arc BD must be 95 degrees. Okay, then we get into a couple of these ideas of finding the arc length. Okay, so we have a circle here. We know that the radius is 3. And we know that the arc measure equals 45. So let's think about what our equation was. We knew that the arc length and the circumference have to be in the same ratio as the arc measure is related to 360. So if I want to solve for this S, I got to plug in what I know. Okay, so I know my arc measure is 45. I'm going to put my circumference in a minute, and I'm going to divide that by 360. Let's take a minute here to step aside and find that circumference. Remember that your circumference is always 2r times pi. So we have 2 times 3 pi, which is 6 pi. Leave your circumference with that pi in it. Your answer is more exact. Do not type that into the calculator. Leave that pi just how it is. So we want to put the numbers together. 45 times 6 is 270. Leave that pi just how it is. Now, if I want to simplify this even more, you might plug it into a calculator, or you might simplify that fraction. It's going to simplify down to 3/4 pi. Okay, let's take a look at one more problem like this. Now, in this problem, you again will notice that we're given a circle. We know that it's going through the center. We know that our radius is 4, and that our arc measure is 225. And so I want to remember that the length of that arc in relation to the circumference is the same as the length of that measurement in relation to 360. Those are going to be equal proportions. So if I want to find my S, I'm going to plug in my arc measure times my circumference that I'll fill in just a minute, divided by 360. Let's find that circumference. Our circumference is always 2r pi, which in this case is 2 times 4 pi, or 8 pi. Remember, leave that pi in there. Okay, so I want to continue doing this math here. I'm going to put the numbers together. So I'm going to get 1800 divided by 360 times pi. We want to simplify those numbers, but you can either plug this part into the calculator, or you can simplify that fraction, but make sure you leave the pi there. Don't put the pi in the calculator, but also don't forget about it. So when we take 1800 divided by 360, we actually get 5. We've got to leave that pi in there, which means that this length going around the circle right on that arc on the outside, the measure is 225, but the length is actually 5 pi.